We're on lesson 33, unit 6.3. We're going to graph sine and cosine functions. And the first part of this lesson talks about periodic functions. I'm not going to talk about that until I show you what it means. And then when I tell you about periodic, you'll already understand it. That's, I think, the better order to do that in. What we have done so far is we've looked at the unit circle. And with sine, just for instance, we said the sine of 0 is 0. And we said that the sine of 90, just dealing with our quadrantal angles, the sine of 90 is 1. And we said the sine of pi, which is 180 degrees, is 0 again. And the sine of 270, which is 3 pi over 2, is, change the sign, -1. Then what if we kept going? In other words, we could say sine of 0 is, and get a point. Sine of pi over 2, and get a point. Sine of pi, sine of 3 over pi over 2. What about the sine of 2 pi? Well, we're back to 0. What if we went to here again? Back to 1 again. What about to here again? 0 again. Back to here again. -1 again. So it repeats itself every time you go around. That's why it's called a periodic function. It repeats itself within a certain interval or within a certain period. If we were talking about y equals sine x, what would the period be? In other words, how far do we have to go with x before it repeats itself again? Every 2 pi it starts over. So we would say that the sine wave is a periodic function and its period is 2 pi. Now, notice that it only gets so big and so little. It only gets so big and so... Now, what is the greatest value of sine? Ny equals sine x. 1. What is the least value? -1. So it actually has a maximum and a minimum. And it's going to go up to that and down to this and up to that and down to this, and it's going to create a wave, and we're going to look at that wave, but that wave has a maximum height. Now, before we draw the wave, let's talk about this. If this was level water, let's just say we had water, and we had a wave coming in, and it's going to ripple. It's going to ripple up and ripple down and ripple up and ripple down and ripple up and ripple down. If you were going to talk about how tall the wave is, would you say the wave is from here to here tall? Not really, because that's not really how tall the wave is. You see, the level plane of the water is really somewhere down the middle of the tallest it is to the lowest it is. You see, if there wasn't any wave at all and it was still water, it would actually be the blue line, not the bottom red line, you see. And so this right here, this height we call the height of the wave or the amplitude of the wave. And so the amplitude is a wave height, which is really half the distance from the maximum to the minimum. It's actually half of that, you see. Okay? And that's all the fancy stuff we want to talk about today in a sine wave is period and amplitude. We'll talk about horizontal shifts and vertical shifts and a lot of other crazy stuff later like we've done with everything else. But this is all we want to deal with today. Okay? All right, so we understand period is the distance it goes before it repeats itself. It's going to repeat itself every 2 pi. And it's going to be an amplitude of 1 in height because it goes 1, 0, -1. Now let's look how this looks in a table. So we're going to build a table of x, y values, which is really theta and sine theta, right? And we're going to do it with these things that we've already talked about, which are our quadrantal angles. It's going to repeat itself at 2 pi. Well, where are the real big easy ones? We could say, we could put in there for theta, we could put 0.65 degrees, but we don't have that one memorized. We could say 30 degrees, we've got it memorized, but it's not as easy as 1 and -1. The easiest ones are at 0, pi over 2, a quadrantal angle, pi, a quadrantal angle, 3 pi over 2, a quadrantal angle, and 2 pi, a quadrantal angle. Now, we're not supposed to have to use a calculator to build this table. We're supposed to use our memory work from the unit circle, right? And so from memory, we should be able to say that the sine of 0 is 0, and the sine of pi over 2 is 1, and the sine of pi is 0, and the sine of 3 pi over 2 is -1, and the sine of 2 pi is back to 0, so we've made it all the way back to where we started. Now, what we've got over here, we're really looking at polar coordinates. What we're going to do is graph this on a rectangular coordinate system, an XY axis with little square grids, rather than polar where we're dealing with angles. So if we were to draw a normal XY axis and try to label that, we could label it 1, 2, 3, 4, but this is not in terms of 1, 2, 3, 4, it's in terms of pi. But don't forget that pi really is a number. It's what? 3.14, bloody, 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 bloody. So we're going to label our grid with the x's that we chose. We're going to label it as pi over 2 and pi and 3 pi over 2 and 2 pi. And we're going to be mathematically inclined enough to know that this is about 3.14 and this is about 6.28 if we actually put numbers. And that pi over 2 is 1 point something. But we like it in terms of pi because we're dealing with trigonometry, you see. And then for my y values, you see, I'm just going to really go up to +1 and -1 because that's my maximum and minimum. It's not going to get any bigger than that, and it's not going to get any smaller than that. So everybody see why we made our grid the way we made our grid? If you put it in the graphing calculator, you would make your x minimum 0 and your x maximum 2 pi. You'd hit 2 and then do the pi symbol, second up arrow. And you'd make your x scale pi over 2. And it'd change it all to these crazy looking decimals in your calculator. Okay? Now let's graph this. Let's see what's happening. If we have the sine of 0, what was the sine of 0? 0. So my sine wave starts with a point right there. And then the sine of pi over 2 is 1. There's my maximum. The sine of pi is back to 0. The sine of 3 pi over 2 is -1. There's my minimum. And my sine of 2 pi is back to 0. And so I could actually draw my sine wave, which would look like that. Now that's one period of the sine wave. It's the period between 0 and 2 pi. If I went on out to another, and another, and another, and another, then this would be 4 pi all the way out to here, right? And halfway between would be 3 pi. And 2 pi is actually 4 pi over 2, so this would be 5 pi over 2. And 3 pi is 6 pi over 2, so this is 7 pi over 2. And so what would the sine of 5 pi over 2 be? Back to 1. The sine of 3 pi, see this would be 5 pi over 2. It'd put us all the way around and back to there. And then the sine of 3 pi, back to 0. 7 pi over 2, back to -1. 4 pi back to here. And we get another, wave just like the first wave. So we say that this is a periodic function because it repeats itself within the period of 2 pi. Now we could take that backwards in our mind, which might be a little harder than forwards in our mind, but we got to really think about reference angles and where we are. Okay? Everybody said we created a sine wave using our knowledge of the unit circle. What would you say the period was then? The period is 2 pi. It's the we went before it began to repeat itself. What would you say the amplitude was? 1. It's the height of a wave from level to maximum. Okay? So amplitude and period are some things that we're kind of putting in our brains a little bit. All right. Everybody see how we got that? All right. Now, let's go to the cosine wave. So we're going to start again, but this time we're going to start with y equal cosine x. And we want to think about cosine in terms of the unit circle. We've got 0, pi over 2, pi, 3 pi over 2, and then all the way back around is to 2 pi. And we want to talk about cosine. What is the cosine of 0 from memory? 1. The cosine of pi over 2? 0. The cosine of pi, change the sign when you go across, negative 1. The cosine of 3 pi over 2, back to 0. Cosine of 2 pi, we're to 1 again. And then if you keep going around, you're back to 0, back to negative 1, back to 0, back to 1, etc., etc., etc. And so it repeats itself again every 2 pi. It repeats itself every 2 pi. And so we can say that the period for cosine is the same as the period for sine, which is 2 pi. The distance actually goes before it repeats itself in the graph. The best way really for us to understand how to graph is to build a table. I mean, whether you do that in your mind or on paper, it's the same thing that's got to happen. So we're going to build a table of x, y values, which is really the angle theta and the cosine of that angle theta. And we could plug in 10 degrees or 40 degrees or 60 degrees, but we want easy ones. And the easiest ones, again, are the quadrantal angles that are between 0 and 2 pi, and the quadrantal angles between 0 and 2 pi are 0, pi over 2, pi, 3 pi over 2, and 2 pi. You might kind of start programming in your mind that we're trying to get 4 sections. In other words, we've kind of divided our period into 4 slots. Are you seeing that? It took 5 things to get 4 slots. You understand if you build a fence and you want 4 gaps, how many posts does it take to make 4 gaps? It takes 5 posts to make 4 equal gaps. Can you see that? So we got 4 data items, but we actually have 4 spaces. And we're going to start seeing that as we do this. So you need to start realizing we kind of need to divide sine into 4 chunks and cosine into 4 chunks. And to do that, we need 5 numbers to get our 4 chunks. Here's what I'm trying to tell you. If we took 2 pi and we divided it by 4, are y'all watching what we're doing? If I take my period 2 pi and I divide it by 4, I get pi over 2. So my chunks are pi over 2, you see, plus pi over 2. So I'm making pi over 2 gaps. I want 4 equal gaps. So I'm going to take my period 2 pi, divide it by 4, which tells me each gap needs to be a pi over 2 gap. That's going to become important when it gets harder, okay? To figure out what size each gap needs to be, take your period and you divide it by 4. Okay. All right, so that's something that's going to help us later. All right, so from memory we know that cosine of 0 is 1. Cosine pi over 2, 0. Cosine pi, change the sign, negative 1. Cosine 3 pi over 2, 0. And cosine 2 pi is back to 1. And then we could create that on a rectangular coordinate system. We started over there with that circle, a polar coordinate system, and we're going to graph it on a rectangular coordinate system. Now again, our gaps are pi over 2. We figured that out by thinking I need 4 equal gaps. My period is 2 pi. 2 pi divided by 4 is pi over 2. So I'm going to make my x scale, if you're going to put it in the calculator, pi over 2. And then another plus pi over 2 would be pi. Plus pi over 2 would be 3 pi over 2. Plus pi over 2 would be 2 pi. The maximum and minimum are still 1 and negative 1, right? So my y is going to go up to 1 and negative 1. It's going to just bounce back and forth between negative 1, 0 and positive 1. Okay? But it starts in a different place. Where did sine start? If we started with 0, started at the origin. Cosine doesn't, though. Cosine of 0 was 1, so it starts up at 1. And then the cosine pi over 2 was 0. Cosine pi is negative 1. 3 pi over 2 is 0. And 2 pi is back up to 1. It looks just like a sine wave. It just started in a different place. So we kind of started like halfway through a sine wave, kind of, sort of. It looks like. Now that's 2 pi. We went one full period. But what if we continued on to 4 pi and 3 pi and 5 pi over 2 and 7 pi over 2? Are you getting the idea that you have to know something about fractions to be able to do trigonometry? And the calculator doesn't always help. You got to kind of be able to do it in your head. You get kind of jammed up. So this is going to repeat itself. It's going to be next. 0, next. Negative 1, next. 0, next. Positive 1. And by the time we do that, it really looks like a shifted sine wave, because it just started in a different place and it went to all the same numbers. It just got there in a different order. Everybody understand the looks of a sine wave and a cosine wave? So what is the period of a cosine wave? Whoops, I missed. 2 pi. It began to repeat itself at 2 pi. What is the amplitude of a cosine wave? 1. Okay? And that's going to kind of be important to us later. Now, let's go to the homework sheet on 33 to 35. And I'm going to do number 1 here, and we're going to try to show you what they're trying to ask you. And when you answer this question, you've got 3 choices of how to answer it. If I let you use the calculator, you can plug it in the calculator and it'll just kick it out. If I don't let you use the calculator, then it has to come out of your head. It can come out of your head by using the unit circle. By using the unit circle, the polar coordinate system. Or you can think about these waves going up and down and where it's going to end up with when it gets to that place. Okay? So let's just look at this. Question number 1, and I'm going to leave all this mess up here, so I'm going to write this in black up at the top. Question number 1 was, what is the cosine of 8 pi? Okay. Now, first of all, you might think, well, where is 8 pi? Well, if I start here, I'm going to go 2 pi, 4 pi, 6 pi, 8 pi. I'm right here. Cosine is 1. Answer's 1. We just went around and around and around and around, and we ended up at 0 again, and the cosine of 0 is 1. Or you could say, well, it actually said find each value by referring to the graph of the sine or cosine wave. So if you actually did what it said, you would be thinking this. I'm going to start at 1, and when I get to 2 pi, where am I going to be? At 1, so where am I going to be at 4 pi? 1, 6 pi, 1, 8 pi, 1. You see how you would be using your sine wave. At 2 pi, that's right here, I'm at 1. It repeats itself every 2 pi, so it's going to repeat itself 2 pi down the road. So at 4 pi, I'm at 1 again. At 6 pi, I'm at 1 again. At 8 pi, I'm at 1 again. It's a periodic function. Well, if we say at 2 pi, you see it doesn't matter if we're looking at the bump on the wave or if we're looking at the unit circle, we're still going 2 pi. Because we should, in our mind, interconnect all those thoughts. Now, let me show you one other thing. You know that what we could do is say, okay, I change this into whatever's left if I take circles out. Now, if I take circles out, what am I really doing? I'm finding the reference angle, okay? So we could take out a 2 pi and take out another 2 pi and take out another 2 pi. And let me just talk about that. We might have something where we took out a 2 pi and we took out a 2 pi and we took out a 2 pi. But then it may be after that there's not enough to take out a 2 pi, but we can take out a pi. And after we take out all our 2 pi's, and then we take out all a pi, we end up with that. And so we find out, well, we went around 6 times, then we went halfway around, and then we went 30 more degrees. So if I went around and around and around, and then I went halfway around, and then 30 degrees, I'm in quadrant 3. That's important because we know what's positive where. So my reference angle is 30 in quadrant 3. So we're going to take out 2 pi's and take out pi's until we can figure out what quadrant we're in and what reference angle we're in. So if we did it like that, we could say, well, 8 pi is really 0 plus 2 pi plus 2 pi. Or I could say it like this. It's really 0 plus 4 of those 2 pi's, right? Now, if I take out all those circles, where am I at? 0. So really, the cosine of 8 pi is really the same as the cosine of 0 plus 4 circles. You take out the 4 circles, you got cosine 0. Cosine 0 is 1. That'd take us back in time a little bit to where we started, just to try to find some reference angles by taking out circles and semicircles and seeing where we land. Okay? Any questions on that? All right, so now let's go to question number 2. And question number 2 was sine. So let's quickly rebuild the sine, if I can quickly rebuild the sine. I think I have time to rebuild it. This is good brain practice anyway. So we're going to take the unit circle, and we're going to say, okay, we got 0, and we've got pi over 2, and we've got pi, and we've got 3 pi over 2. And we're talking about sine, and the sine of 0 is 0, and the sine of pi over 2 is 1, and the sine of pi is 0, and the sine of negative 3 pi over 2 is negative 1. And when we get back to 2 pi, the sine is back to 0 again. And we can see that happening in the graph of the sine wave from pi over 2 to pi to 3 pi over 2 to 2 pi. It's going to bounce from 1 to negative 1 and 0. And so we know that the sine of 0 was 0, so it started here at pi over 2. It's up to 1, back to 0, negative 1, back to 0, and it's going to be doing this. I did that faster because we already did it slow. So our mind just works through that, you see. And so then we get to question number 2, and question number 2 says the sine of 7 pi over 2. And it actually says, think about the graph of the sine wave. Now, that's going to be hard for us, wouldn't you think? Because fractions are kind of ugly. Which one of these dots, you see my dots, does 7 pi over 2 connect to this one, or this one, or this one, or this one, or this one? Well, you may say, well, it connects to 3 pi over 2. How do you know it connects to 3 pi over 2? Well, if you had 3 pi over 2 plus 4 pi over 2, isn't that the same as 2 pi? Then what you would have is 7 pi over 2. So 7 pi over 2 is 2 pi away from 3 pi over 2. So the period repeated itself, so it must be the same as 3 pi over 2. And if the sine of 3 pi over 2 is negative 1, then the sine of 7 pi over 2 must be negative 1 because it revolved its way around there. Okay? So, everybody see that? Let's make that happen on the unit circle. Let's just make pi over 2 jumps. We want 7 of them. That's pi over 2. 1 of them, 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, 7 of them. That was not that bad. We want pi over 2 jumps. Pi over 2 is 90. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. Okay, just work your way around the circle in pi over 2 jumps, which is 90 degrees at a time. Or you could say here, I need 1 of them, 2 of them, 1 of them, 2 of them, 3 of them, and then 4 more of them would be a whole circle, so I'm back to where I started, and that might boggle your mind some, but let's look at it this way. Let's say, okay, the sine of 7 pi over 2 is the same as the sine of what plus taking out a circle, okay? If we took out one circle, what would we be taking out? 2 pi, which is 4 pi over 2. So you're saying I need to take out a circle. And if that's not enough, I'm going to take out a semicircle. So I'm going to take out a circle, which is 4 pi over 2. And if I take a 4 over 2 out of a 7 2, then I'm left with a 3 pi over 2, you see. And that 4 pi over 2 is really the same as 2 pi. So if I take a circle out of 7 pi over 2, I'm left with 3 pi over 2, and I'm supposed to have memorized that that's negative 1. And so now I'm just going to think about sine 3 pi over 2 is negative 1, and that's what sine 7 pi over 2 would be. Now you have to be able to do some fractions in your head here, or it's not going to be very easy for you to do this part of trigonometry, okay? Any questions on that? Okay, is everybody good so far? Question number 3. Question number 3 says, find the values of theta for which each equation is true. Cosine theta is equal to negative 1. Back to the unit circle, which is where our graph came from. When we're talking about cosine, cosine is of 0 is what? 1. The cosine of pi is negative 1. And then it's 0 here and 0 here. There's one place that cosine was negative 1 when you go around the circle. It's right here. So it's at pi. But we want every possible answer. So when will it be negative 1 again? When we go all the way around. Leave a space. If you go all the way around, you're back to pi. Now, how many times could we go all the way around? As many times as you want to. an integer n number of times. So this is the set of all times that cosine is negative 1. Cosine is negative 1 at pi. There's your start. Plus, every time you go around, and you can go around over and over and over and over and over. Okay? 2 pi n. You could go around backwards. Negative. You could go around none, and you'd be right there. Okay? So n represents any positive or negative or zero, an integer. It's positive, negative, or the number 0 itself. Any questions on number 3? Now, this is a little more challenging. These can be a little harder than that. Let's say that we had the sine theta is equal to negative 1. Sine theta is equal to negative 1. That wasn't a very good theta. Now, when was sine theta negative 1? What? At pi over 2, sine was what? 1. And so it became negative 1 at 3 pi over 2. So the first time it happens is at 3 pi over 2. But when is it going to happen again? Every time you go around again. And how many times could you go around again? An integer number of times, either forwards or backwards. So this is the set of all times that sine theta is negative 1. Okay? Any questions on that? Now, we've got a couple more problems at the bottom of that worksheet, and I'm not going to show you those yet. I'll do that in another video, but I want to ask you this. We're going to throw one other thing at you. I'm just going to call it example. Tangent theta is equal to 1. I want the set of all times that tangent theta is 1. See if you can tell me that with the amount of time we got left here. Think before you speak, though. I want the set of all. Where's tangent theta 1? Let's draw the unit circle. We got to go back in our mind. What's that? Pi over 4. Very good. So let's back up to that. Remember that the tangent of 45 degrees, which is pi over 4 in radians, is equal to 1. The tangent of 45, or the tangent of pi over 4, is 1. Now, is it going to happen again every time you go all the way around? You only have to go halfway around, because tangent is positive in quadrant 3. That means it's going to happen again there. And this is pi, which is really 4 pi over 4. It's a whole pi, which is 4/4 pi. So this is going to happen at 5 pi over 4, correct? But how far apart were they? They were 180 degrees apart instead of 360 degrees apart. They're only pi apart instead of 2 pi apart. So the first time that tangent theta is 1 is at pi over 4. But it gets there again in pi instead of 2 pi. And how many times could you go back to that? Boom, 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 as many times as you want, right? So that is the set of all times. That tangent theta is 1. So when we get to tangent, it repeats itself. What would you say then that the period for tangent is? The period for tangent is pi. The period for sine is 2 pi. And the period for cosine is 2 pi. Okay? Everybody see that? Now, we're not to tangent yet, but I thought you needed to see that. All right, we're going to stop there today, and then next time that I'm teaching, I will finish up the lesson 35 part of this, and then we'll move forward.